So this is a machine learning project NumPy assignment where we solve approx 15 questions of the NumPy which is related to the machine learning. So first question is, what is Python library and why do we use Python libraries? So basically I answer that a Python library is a collection of pre-written code and functions that extend the capabilities of the Python programming. It means you can just focus on the business logics, and libraries provide the reusable module and the functions that develop can be easily incorporated into their Python code. Means if you use some mathematical computations, so you don't need to write all the mathematical code, but you just implement the methods with the help of the math library. And Python's computing mathematical computation use NumPy array for the scientific calculations. And for why we use for coding reusability, means we can use again and again. Second one, efficiency, we increase our efficiency. And modular code maintainability, means we can maintain our code in modular form from any project. More focus on the domain specific problem note rather than coding. So community contributions, if someone already solved some question, some problem using the coding, then he code the modular and he make as a library, so another person use this library as a function. The second question is, what is the difference between numpy array and the list? So we know the basics of the database dsm data structure of the python is list, and the numpy array is a library numpy. So both are the useful for the python. If you use a less memory, then we use list. If you use more comfortable or more want to in the computation part, so that time we use numpy array. So first one is memory efficiency, means numpy array is more continuous and better memory efficiency when we need same data types of calculation, but python list is store the element with the different data types, so we can calculate on the different data types at the same time. And the performance, so we know the numpy array is optimized the numerical operations, so it is faster than the python list. And then second is, third one is functionality. So numpy array is more extensive mathematical function. You can use approx all the mathematical functions as a method in using the numpy array, but in list they have some basics computations mathematical equations can perform. Then fourth one is ease of use, means you can, when you create a mathematical numpy array, so that time you use a concise syntax for mathematical operations, and which is very helpful. And the type of stability, means when you use the list, they have some different data types can be stored, but at the numpy array we use only the single data types we use store there. Okay. So the questions first, the third question is, we first find the shape, size, and dimensions. So what is shape? Shape is basically we how much row and column. Size means how many elements are there, and dimension means it is one dimension, two dimension, three dimensions. So the I will import the numpy array. If you use a simple list, so the simplest give me a array data types, that is a list. But when we convert into the numpy array, so np.array, we convert the array into a numpy array, and after that we just perform the mathematical array function, numpy function in there. So if you want to find the shape of the array, so just use the array dot shape, and we want size, the array dot size, and dimension for n dimensions. When we print, they have shape of array is 3 by 4, means 3 column and fourth row 3 row and 4 column. And the second is size of array, means how many elements are there. Dimension is 2 dimension. So the fourth question is, write python code to access first row of the element. First row means 1 2 3 4 5. So just first of all we convert the array into numpy array. After that we just access the using the index numbers, that is array dot 0. If you are using list, the same answer, but have some column because it is in the list form, because he is a nested list na. So he is one list pink yellow, and the second one is another list. So inside list, a list variable store. That's why access like this next. And we use numpy, so we can just access as a array. So how do we access the element of the third row? So if I want to access the third row, means 0 1 2, because index number starting from the 0. So that time we use 1 2 3. So 3, that is 3 row, and the fourth column. So 1 2 0 1 2 3 4. So that is the 12th. So I want, how can I access the 12th element only? So just using the index number we access. So first convert, and we just use index means 0 2 means row number 2, and the column number third. So the output will be the 12th. The sixth questions is write a code to extend all odd indexes element from the given array. So what is the meaning of the questions is you can just 0 1 2 3. So 1 3 is my odd index number, so I extract 2 4 6 8 10 and 12. So I write question, I write the code, then I will explain. So now here I write the logic. First of all, we use the numpy array which is already created on the above question, so I not to write again. And the first we using the for loop to collect the row from the 0 to shape of 0. Shape of 0 means you have to know the meaning of the, when we collect the shape. So the first is column row and the second is column, so we need to use as first. So index number is 0, so we use the shape of 0. So that's he access the 0 zeroth call roll number. And the second, if you array dot shape dot 1 means he collect the column number from the shape. And we go for the loop to 0 to shape. And we don't need even number, so we don't equal to 0. So the if the logic is true, that time we print the number of the array. So the number of the array is 2 4 6 8 10 12. So this is our logics, and this is the answer. So now the next question is, how can you generate a random 3 into 3 matrix with the value of 0 to 0 and 1? Means when we create a matrix of 3 into 3, and the value in the this matrix is 0 to 1, means we have used the random functions to generate a matrix. So first I write the code, then I will explain. Here I just show you how I create the logic. So first we create a normal matrix with the 0 of 3 by 3 ka. And after that we have a round function, and we use the random function to create a random numbers from 0 to 1. Just like example for 1 0.16, this is a one random number. And to define the how many numbers after the point. So there is 2 points, two numbers after points, so decimal, so we need 2 point decimal numbers. So that's why I choose, if I we choose this for 1, then the random number of after the decimals is only 1. So this is our logic, and we just do like uppercase. So we just use 4 column, 4 in 4 row and 4 column, and then we just put the value of random number in the matrix index number. So this is very basics, and now let's implement. So our logic is built, so I run. So this is our logic, and press enter to run our logic. So the first is 0 0, then the random number we have generate, and generating after random number we again do a calculations. After calculations normal. So this is our random function. So 0 0.3 0 0.4 7 7 7 7 7 6 2 7. So this is our how I generate our random number. So now the next question is, describe the difference between np.random.rand and np.random.randint. What is the difference? So you have just to explore this by the choosing or some articles, or just experiment with the code. I'm just experiment with the code. So let's this is our basic logic which I use here. So if you use a random, and so it get some dimensions of array which pass there, and after passing you return a sample from the standard normal distribution, which is standard deviations like a bell curve, and there is a mean of 0 and variance is 1. So this is a normal Gaussian distribution with when you use a random n. But when we use a normal random function, it give you a range between 0 to 1 only. So in before condition I use a random n, so this is give me the random functions. So just like that, it's give me a random function. So just I use and create some list from there where write some comment because so the random rand is create a range between the 0 to 1, which is so below the output section, and the second one is random dot rand, and which is give a value which is follow the normal distribution function. And what is normal distribution function? So the any curve line or any data which has a standard mean is 0 and the standard deviation is 1. So this all basically follow the normal distribution. So I hope you understand the difference between that and the now next is write a code to increase the dimension of the following array. So maybe the dimensions, so you use 2D, so I need to create a 3D, 4D, 5D. Basically we create this array into the higher dimension array. So how we create, so I just code then I explain. Okay, so we code now. So this is my original array. That is a 2D which previously we use in many questions. So this is our 2D array we know already. So we convert this into a higher, that means we convert into new array, that is 3, and we just using the new axis, we just add the axis on the value. So the first one is using the new axis formula, this is new axis formula, and the second one is using the np dot expand dimensions. So if we expand dimensions may, what we have to do, we just use original array, that one, and we use axis equal to 2. 2 means we have increased by the 1 and the 2 dimensions. So now this is the first dimension, second, third, because any vector is a one dimensions. If you use again another, that is called, so basically we define the dimension means how many you have a vectors in same. So this is a one vector. Vector, what is vector? Vector is a single dimension array. So if you pass any value in between two a square bracket, this is a vector. So this is a single vector. Any in this between have many values, but it is still a single vector because you have one bracket. When you pass the double bracket, just like to do, this is first, second, first one is this and the second one is from in first to last, this is the 2D array, and then when we create again the third one, so this is a third array. So when we run this value, then we look like this, third dimension. And what is the dimension of the array? That is the third dimension. So I hope you understand how we use to code this. So the next question is how to transport. So basically transpose any array in the list is very easy. Just you can use the array dot p, or you can just np dot transpose, then pass the array, just use. So I know now code. So this is our original array which have already know, and we just I say we just go for the array dot t, so it's transpose the array. And the next is we can just use np dot transpose, both are same, you choose whatever you want for your data set easily. So just enter and the answer will be look like transpose of the array. Transpose means if the row value into column and column value into row, this is the basic meaning of the transpose. So my row value is 1 2 3 4 5 6 and 9 10 11 12, but I change into the row value into 159, that is column value 159, that is column value into a row and row into column. So this is the basic meaning of the transpose. So I hope understand. So consider the following matrix. So we have a two matrix, matrix 1, matrix 2. They have both are 2D, and just we perform the sum operations using the Python, that is index wise multiplication. The first one is multiplication, second one is matrix multiplication, which is use any dot product and add both of the matrix plus for and the subtract minus and divide. So now perform one by one and then I will show you. I hope you understand. So just basics operations using the index now index wise. So you just use the multiplication operator, arithmetic operator. If you use a matrix multiplications, that time you use the np dot functions of basic maths. We if you read in 11th 12th, so if you calculate any matrix multiplications, you use dot product, and the addition we just use the arithmetic plus operator, minus operator, and the divide for divide operator. So these are our basics operations which you do here. So after running you have some answers. So wait a minute, something is wrong, keep waiting. Yeah, so this is our answer will be so here. So this hope you understand. So the index wise is answer will be the difference and the dot multiplication is different because of the array scalar and vector array have a alag alag means different mathematical functions. So the next question is which function in NumPy array can be used to swap the byte order of array. So basically we use some NumPy function we have, and then I will explain I first code. So we have a function in NumPy array that is a byte swap. So just we swap the byte into a swap array. So bus print swap underscore array. So we just print the swap array so you can see how it's look like. You see the byte array because my original is 1 2 3 4 5, but it convert into the byte swap. So we don't know which what is the number, so it's converting to the byte mean byte size. What is the significance of np dot linear algebra dot inverse function? So it basically do the value into a linear algebra. So first code, just we here create a one matrix that is a square matrix and another one compute with the link algebra linear algebra dot inverse. So with that he could pass the inverse functions and it is so the inverse of that matrix. Why we use inverse? So it is compute the inverse of the matrix, so that's why you use. So keep waiting because the system have maybe some error. So our original matrix is 2174. So when we inverse they have changed the sign of odd number, so 0 1 1 and the 4 2 2 4. This is our, and product of a and its inverse should be 1 0. So always it's convert always show the identity matrix when we convert the product of a and its inverse means a into a inverse. So this is the our full mathematical computation answers. So the next one is np dot reset. So you just basically change the dimension of the array without changing the data. So for example we have used have a 2D dimension with two row and three columns. So we convert the three columns and two row because the initial value is two row and three column. So I want to change it into three row and two columns. So this is our so print reshape array and enter. This is our reshaping. So 1 2 3 4 5 6. So it's change the dimension of the array. So basics. So we just np dot reshape. The next question is what is broadcasting? It is very useful functions in NumPy array, and it is basically used Broadcasting is generally used to NumPy to perform the operations of the array in different shapes. Means you have a different shape or size of the array and calculate or do operations between them. So that time we use broadcasting to change into one shapes into another without changing the data. So we want to do with between area of different shapes without explicitly reshaping them. We don't change the shape of the data actually. So but NumPy automatically broadcast the similar a smaller array because he convert itself into a smaller array and that one to the larger one. So this makes it easier to perform the operations on the different dimension without the need of explicit locking. So if you using reshape function, so that without using reshape function, it calculate or the any matrix and it's give you a result without changing the value. Here I show you example. So just create the array here. And the array will be the 3D and the second one is one dimension array. So how we add both of them because the dimension is both are different. So the use the concept of broadcasting, it is automatically done by the array. So the first one is USG. I will show you example. NumPy array automatically broadcast the smaller array means one dimension into the shape of the larger one. So it's automatically convert into 3D and convert into 3D itself, and after that they calculate the performance of plus operate plus and then result out. So for example you have a 1 2 3 4 5 6 7 8 9. So they have add 10 plus 1 11, 10 20 plus 2 22, 10 30 plus 3 33, and 10 plus 4 14, 20 plus 5 25, 30 plus 6 36, and then 10 plus 7 17 20 plus 8 8 28 30 plus 9 is 39. The result will be look like this. So the answer for you look like this. So the broadcasting is used when we have calculate the deep learning neural networks. At that time it's very useful. So I hope you understand. And when we create now y equal to ms plus c and we define the neural networks, at that time we use the broadcasting concept without knowing when we pass the weight with the bias. So I hope you understand these all 15 questions. If you any problem in this question, feel free to question on the comment. I will answer. Thank you.